Hello, the purpose of this video is to review how we use the calculator to do a numerical analysis of the quantitative data set of test scores from the standard deviation worksheet you had for homework. So I asked you to put the data into L3, and to get to that you go to Stat, Edit, and you can see I already have the data in L3. And you can just go ahead and input the data much like you would on an Excel spreadsheet. Hit the number, hit enter, and keep going down. Okay, so the first thing we want to do is just get a feel for the data, and the best way to do that is to make it into a picture. And our calculator allows us to do a bunch of pictures, but we only have one data set, so the pictures that we are going to be interested in are the histogram, a modified box plot, or a box plot. So the first thing I do is I turn the plot on by putting the cursor over and hitting enter. Then I use the arrows down to the next row of types, and I scroll over and I'm going to go to histogram. So I hit enter, so I get that picture. Then I want to point it to my list, which is in L3, so I go to second 3, and that calls up that data set. And my frequency, because it's a single list of quantitative data, I go ahead and leave the frequency at 1. I then hit zoom, and I'm still not sure why that works that way, but I go zoom 9, and if you were to scroll down to 9, and you'd see it says zoom stat. So zoom 9 is the quick way to do it. Hit enter, and it automatically pops up a histogram, and usually it's 5 bars. And if I want to change the number of bars, I can hit window and change my scale. So if I want to make there more variation, I can make smaller bars and hit graph. Or if I want to make less variation, I go back to window, and it was at 20 before, so maybe go up to 40 on the test scores and see what happens. And you can see I have very little variation there, so maybe that's not a good one to show. Let's go, instead of 40, let's go to 30. Okay, so you can play around with that as you see, and it almost looks like I get a normal distribution now. So I can change the shape to however I want to best communicates the data in a way that I want to communicate it. Okay, so that's my numerical analysis. I'm going to go to zoom stat and get back that picture again. That's the original picture. These are my test scores. But I can also change the picture to a modified box plot, which will show me the outliers. Oops. And I can change what it marks with, and again the frequency is 1. Do zoom stat, and you can see there is a modified box plot, and I do not have any outliers. And if I want to go to just the regular box plot, then I would expect actually to see the same picture because I don't have any outliers. But let's do it anyway and just double check. And you can see I have the same picture. Okay, so that's turn into a picture. If I want to find the 5-number summary from my box plot, I can just hit the trace button and move my cursor. There it is in the median, and you got the descriptor down here below. And Q1 is 33, minimum is 22. My median is 68.5 because I have an even number of data points, so I'm going to take the halfway between the 2 center data points. And then my Q3 is 99 and my max is 102. Alright, so that's one way to get some of the numerical analysis. Another way is to go ahead and hit the stat calc and do 1 var stats. And when you do one bar stats, again I changed it to my list 3. I want to be careful about which list I'm doing. Frequency, I don't put anything in there. And hit calculate. And my one bar stats gives me the X bar. Anything with a bar over it means mean. So this is my mean for that data set. We won't really use the next two. And then the fourth one down is sample standard deviation of X of 30.4. And remember, that means that the only difference between the S sub X and the sigma sub X, just below it, is the denominator in creating the standard deviation formula, or following it. This is n minus 1, and this is n as the denominator. Okay, if I scroll down here, you'll see the actual numbers that are used to form the box plot for the 5-number summary. Okay, so we've got some statistical information here to describe our data set, as well as a picture. And so using the calculator commands makes it pretty simple and straightforward. And if you're good at getting confident at inputting the data, then this is a big help on any type of test. Okay, so the last part that I want to cover is, well, the manual part of doing the formula for standard deviation. And we'll go back to the list, and to go through the manual part, what we do is we want to create a formula. We go up into the header and then hit enter, and then we build a formula very similar to Excel. In this case, we're saying I want to take L3 and I want to subtract the average, which we calculated to be 66, and I want to do that for each number. So I hit enter at that point, and that fills in my distances. I want to sum it, and remember we would expect that to be 0, and the process for summing it would go to second stat. Oops, I got to get out of here first. And I go to second stat from the home page, go across to math, and you can see number 5 is my sum. So I take the sum of L4, and no surprise that it's 0, because we've got values up above our mean and values below our mean, and when you sum them all together, if it's truly the mean, it should be 0 or really close to it, depending upon your rounding. Okay, so that means that we need to do something mathematically to make sure that the distances aren't positive and negative, but in fact they're always a positive distance, because that's really what we're interested in measuring. So yes, you can use the absolute value process, and it gives you a decent one, but statistically we know through experience that a better measure is to use the squaring of the distance in order to make sure that it's positive. So if I'm going to square the distance, again I go up into my header, I hit enter, and I say, look, I want to take L4 and I want to square each value in L4, and I hit enter, and that squares each value. Go back to my home page, and I take the sum, and I can recall up the sum by hitting second enter and then just changing it from L4 to L5. And now I have my sum, but I'm not interested in the sum of the distances squared. What I really want to know is the average distance. So therefore, as I said before, if I'm doing a sample, then I'm going to use n minus 1, just like on your worksheet. So that would be 10 minus 1, which is 9. So I would go ahead and take this number here and divide it by 9. And that gives me 926.44. But again, as a reminder, what we have to consider is the fact that we squared, so we've valued the real distance. So to get it back to our original units of measure, we take the square root of this value. Now this 926 in statistics is called the variance, because it's the average distance before we take the square root. So that's what the variance is, and that'll be important later on. But right now, to get to the standard deviation, we take the square root of that, and to do that we go to second squared, which is the square root symbol, and then I can either input that number or I can have the computer calculate it or input it directly by saying second negative, which makes it recalls your last answer you did, and I hit enter. And that's the 30.437, which coincides when I go stat, calc, one var stats, calculate, and you see the 30.437. So that, hopefully you'll find this video helpful, and continue to gain confidence using your calculator, so that when the AP test comes, you will feel very confident and comfortable, because it's an excellent tool to use. Thank you for listening.